Okay, so now in Chapter 7, we're going to look at the second type of inferential statistics. It's called hypothesis testing. In hypothesis testing, we know the population parameter, which is different than in Chapter 6 when we were trying to estimate an unknown population parameter. With hypothesis testing, the population parameter is known, but we're going to test a claim to see if it has changed in some way. So we're going to look at 7.1, 7.2, and 7.3, knowing that the procedures for a hypothesis test for proportions and the procedure for a hypothesis test for variance and standard deviation, the procedure is the same, the formulas are slightly different, and if you need to learn about hypothesis test for proportion or standard deviation or variance, you can read that on your own. There'll be no questions on homework or exams for proportion or standard deviation. So let's get started in 7.1. In 7.1, we're really going to just need to learn some terminology. And so the first thing, a hypothesis test. The hypothesis test is a process where we're going to use sample statistics to test a claim about the value of a population parameter. For example, suppose an automobile manufacturer claims that the average mileage is 50 miles per gallon. That's the claim, and we want to take a sample to test this claim. And if the sample mean differs enough, now that's going to be the key to this section. Does the sample mean probably differs from 50, but does it differ enough that we can say the advertisement is wrong? So there's in a hypothesis test, we have a statistical hypothesis. In fact, we really have a pair of hypotheses, one that represents the claim and the other that is its complement. Recall from Chapter 3, an event and its complement. The complement of an event is everything that's not that event. So the claim and its complement cover everything, and there will be no overlap between them, which means when one of these hypotheses is false, the other one must be true. The null hypothesis is denoted with an H sub 0, known as H naught, and it always includes equality, less than or equal to, or greater than or equal to. Why don't you take some time now and make a note of what words these symbols go with. Less than or equal to means at most. The word at most means less than or equal to. The word is means equals, and the word at least means greater than or equal to. Then the complement of these symbols, the complement of less than or equal to is greater than, the complement of equal is not equal, and the complement of greater than or equal to is less than. The words for this would be more than, is not, or less than. And we denote the alternative hypothesis with an H sub A. These are complementary statements, which means either this one is true or that one is true, but it can never be the case that they're both true or they're both false. To write a null hypothesis, we need to translate the claim into a mathematical statement, then write its complement. One of those, the claim and its complement, one of those will be the null hypothesis and one will be the alternative hypothesis. Remember, what we're looking for is if the words include equality, then the claim was the null hypothesis. If the claim does not include equality, then the claim was the alternative hypothesis. So if the null hypothesis is less than or equal to, then the alternative is greater than. If the null hypothesis is greater than or equal to, then the alternative is less than. And if the null hypothesis is equal to, then its alternative is not equal to. All right, so let's practice. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Is 61% stands for equals. So the null hypothesis is P, that's population proportion. We didn't really cover proportion, but that's the symbol for it, proportion. Proportion is 0.61, then the complement of equal to is not equal to. Suppose a car dealership announces that the mean time is less than. Well, less than does not include equality. Less than does 15 does not include 15. So that means the claim is the alternative, and then the complement of less than is greater than or equal to. So the complement of less than is the null hypothesis. One more time, the company claims that the mean life is more than 18. More than 18 does not include 18. So the claim is the alternative again, which means the complement of greater than is less than or equal to. No matter which hypothesis represents the claim, the theory of hypothesis testing begins with we always assume the null is true, and we're trying to either find enough evidence to support that or there is not enough evidence to support that. In the end of the test, only one of two decisions will be made. We'll reject the null hypothesis, or we fail to reject the null hypothesis. All right, now, and there's two types of errors, a type 1 error and a type 2 error. The actual truth of the null hypothesis is not known. That's what you're testing. We don't know that. But suppose we do not reject the null hypothesis, and in fact the null hypothesis was true. Then we made a correct decision. But if we rejected the null hypothesis, then we made what's known as a type 1 error. A type 1 error occurs if the null hypothesis is rejected when in actuality it was true. If the null hypothesis in actuality is false and we do not reject it, we have made what's known as a type 2 error. If we rejected it and it was in actuality false, then we made a correct decision. So a type 2 error occurs if the null hypothesis is not rejected when it was false. We have another piece of a hypothesis test known as the level of significance. The level of significance is the maximum allowable probability of making that type 1 error. We denote it by a lowercase Greek letter a called alpha. By setting the level of the significance small enough, then we are saying that we want the probability of rejecting a true null hypothesis to be small. So the probability of making that type 1 error is small. Commonly used levels of significance are 10%, 5%, and 1%. Now the probability of making the type 2 error is known as beta. In this class, all we need to know is that beta exists, and it is the probability of making a type 2 error. We will not be discussing beta any longer in this class. So after we have the null and alternative hypothesis and we have specified the level of significance, then we go out and take a random sample, and sample statistics are calculated. These statistics are used to calculate what's known as the test statistic. The test statistic for, if we're testing mu, which in this class we're only going to be testing population parameter mean, the population mean mu, then the test statistic is an x bar, and our standardized test statistic will either be a z if the sample size is greater than 30, or t if it's less than 30, using the same reasoning that we did in 6.1 and 6.2, deciding whether we're using a z-test or a t-test. The p-value, or also known as the probability value, is the probability that the null hypothesis is true. The p-value depends on the nature of the test, and we have three types of tests: left-tail test, right-tail test, and two-tail test. The type of test is associated with the alternative hypothesis. So let's look. If the alternative hypothesis is a less than, then it is known as a left-tail test. It's easy to see the inequalities pointing to the left-tail test, which means the test statistic is here and the p-value is in the left tail. If our alternative hypothesis is a greater than, the inequality is pointing to the right. It's known as a right-tail test, and the test statistic is here and the p-value is in the right tail. If the alternative hypothesis is a not equal to symbol, this is known as a two-tail test, and we have half half of P in the lower tail and half of P in the upper tail. So P is twice this area shaded here. All right, so let's consider this problem. Let's decide whether this is a left tail test, right tail test, and then shade the area for P. The school publicizes that the extracurricular activity is 61%. What we said that claim was the null hypothesis, which means the alternative is not equal to, which makes this a two-tail test. So half of P is shaded in the bottom tail and half of P is shaded in the upper tail. Less than 50, remember that claim was the alternative, which makes this a left tail test, and all of P is shaded in the left tail. This one we decided a minute ago was a greater than, which is the alternative is greater than, which makes this a right tail test, and all of P is shaded in, sorry, this blue thing should be over here, but it's not. So it's all in the right tail. Now the decision rule is based on this p-value, and the p-value is going to be compared to the significance level, which was stated before we ever started our experiment by drawing the sample. If the p-value is less than or equal to the significance level, then we're going to reject the null hypothesis. Remember, the p-value is the probability that the null hypothesis is true. If this value is small enough, and small enough is less than or equal to that, then it must not be true, and we should reject it. If p is greater than alpha, the significance level, then we fail to reject the null hypothesis. Okay, so steps for hypothesis testing. The first thing you need to do is identify your null and alternative hypothesis. Then specify the level of significance. In an academic setting like this, the significance levels will be specified for you, but in real life, it would be something you would specify for yourself. Then you need to determine the standardized sampling distribution. Is it a z-test or a t-test? Calculate the test statistic. Find the p-value using either the z standard normal table or the t distribution table that we used in 6.2. Then we use the following decision rule. If p is less than or equal to the level of significance, then we reject. If the answer is no, then we fail to reject. If the answer is yes, we reject the null hypothesis. And then we can write a statement to interpret the decision in context of the original claim. That's the end of the theory behind how a hypothesis test works. Let's stop for a minute now and you go try a couple problems, seeing how well you understood the material in 7.1 at the Course Compass My Math Lab website, homework 7.1.